Hi, this is Liam Robertson. My final year project is an animation project within Unreal Engine. Its official title being Advanced Movement within Unreal Engine, though its true purpose was to tackle issues within games with transitions. During my research, I knew I had to study how games function and how animation plays into that part. Deciding to do some book research, I looked into the game animation guide called Game Anim by Jonathan Cooper. This book itself is incredibly insightful and rightly summed up my project as a whole with the quote, "The number of animations can quickly spiral in number, so balance must be found among the desired level of fluidity." Taking this on, I realized I knew I would have to create possibly hundreds of animations within a small amount of time. So I knew with this warning in hand and with a reasonable amount of caution, I set myself a goal. I could prove to myself and I could create the basic aspect of this project within a week in Unreal Engine or pursue the idea. If not, I will switch the project out entirely and move on to something else. But what base aspects was I even aiming for? Well, that's where researching games came in. Judgment is a 2019 action role-playing game. Its movement is based upon Yakuza Like a Dragon franchise, which is made by the same team. This is relevant due to the fact that they've worked in this engine and reused the same assets and animation from within Yakuza Like a Dragon franchise for nearly a decade. Personally, I liked Judgment's design and animation workflows. They have a turnaround mechanic that it easily allows a U-turn at high speeds. They also have a transitional movement from when starting and stopping. The limitations fall flat when you start running and attempt quick turns either left or right. They don't flow nicely. Instead, the appeal of it gets cast aside for the use of quick turns on the spot. That makes no sense for the movement. Even though I believe this game has the best movement out of the following list, I understand the limitations. But I did take a few things from this game that I use for myself. The turnaround mechanic and the start and finish transitional movement. Moving on to my second showcase game, Hitman World of Assassination. This is a 2023 video game that primarily focuses on stealth and strategy. Its functional and basic animation style is just that. Simple. It does everything it needs to do without doing anything extra. If Judgment is the middle ground for animation in terms of a line, then this is the minimal. It's not bad, it's not good, but it's entirely functional. In this demonstration, I have the main character here walk around. You can see there is no transitional movement within the game, it simply goes straight into the movement loop. No start or no stop animations, which are created just for this fact. Instead, this is an extreme when it comes to functionality over design, as we need to do many things, sometimes within a split second in gameplay. Therefore, when it comes to strategy and play, it needs to be flawless. And this is a good example of animation mainly playing into the function, the player's sense of belief when it comes to our protagonist being able to do these feats. This means that the player doesn't expect a lot from Hitman in terms of animation. And this matches very well when it comes to the book Game Anim, which says that animation is simply the tool to express gameplay. During this time too, I played Red Dead Redemption 2, released in 2018. It's an action-adventure crime game based around its main character Arthur, and it had all the features I was looking for. Flawless movement, turnaround movement, transitional turns, and starts and stops. It had all the bells and whistles I looked for when deciding to do this project. But the hardest part about this was finding out that there is no documentation on how they create this within their engine, and they hid it very well behind lock and key. And I would have to theorize that what made this so good had to do with the animation system. And I would have to theorize what made this so good. What did they do to have this animation system? So, due to the time constraints on the video, I would have to summarize it quickly. Red Dead Redemption 2 has an incredibly smart state machine that decides out of a list of idles, gestures, walks, and determines which blends into another. The animation list for Red Dead Redemption isn't released, but it's surely in the hundreds of the main character. That can happen when playing poker, blackjack, sitting at a bar, drinking at a bar, eating, and the rest. But mostly when walking, he can stop, change trajectory smoothly, correctly stop if the foot is extended, and the whole 9 yards. This left me with a long list of features to choose from. Overall, this would be the maximum quality in terms of animation. It is so out of the world in design and quality that it is the polar opposite of Hitman, but not so past Judgment. But Red Dead Redemption 2 has animations that are very specific and don't hold any function outside of looking cool or being immersive. So on the spectrum, this would be the project that has the maximum quality and the highest amount of animations in total. In the end, after researching these great games and seeing what I wanted for mid-range to high animation quality game, this is the list I found. I wanted turnaround mechanics, left-right foot detectors, 8 directions of start, 1 direction of stop, unsheathing mechanics, layered animation, gesturing animation, directional movement and influence calculator, but most importantly, flawless transitional movement between all animations. So I got to work on what I believed was the priority. I knew I wanted a turnaround, and I also knew it was a lot of work. So building a small blocky build of animation, I went ahead and created the animations within a day and started creating the systems the next day. By the time my first build was done, I had 8 directions to start, 1 direction to stop, turnaround mechanics, and the directional movement and influence calculator. Eventually, with all of this out of the way, I knew I could finish this project. I had all the hardest parts of the system out of the way, and I moved on to animation. The next few weeks were just myself making as much animations as possible, and during the time when I was creating the animations, I once again looked upon Game Anim. And with the guidance in this book, he also states, even with a single animation, it is essential to maintain fluidity of motion, and that a large percentage of game animation cycles cycle back on themselves. So it is important again to ensure the player cannot detect when this transition occurs. As such, care must be taken to maintain momentum through actions so the end of the animation perfectly matches the start. To summarize, every loop that a character does must start and stop on a pose that can be carried through to the next animations. So, once again, with all these tips in hand, I create the most important thing, standing and breathing. It's my starting position for 18 animations and the ending position for 2 animations. And once I introduced combat into the mix, I had to create an entirely new string of positions for when you hold the sword, and the transitional movement. So now rising the animation total to over 40. All of these were done as well in quick succession. I had to find a balance quickly between getting the animations done as well as keeping consistent and high level of quality. As eventually I finished all the animations needed. But there was one underlying issue once the animations were completed. The rig was incredibly faulty. I discovered during the animation phase and testing them within Unreal Engine that the root motion didn't work. Now this was crucial for the combat animations to work, as it would take the animation data assigned to the root of the rig and calculate the speed of it and move the character itself as well as with all the other components. And at this point, due to the fact that I didn't create the combat mechanics, yet simply focusing on the movement, I spent 2 weeks attempting to fix the rig. The fault of it was due to the fact that when importing the rig, the bones were not in the correct direction and could only be fixed by my amateurish mistake I made at the beginning, by importing the rig with the mesh and the bones, but also with the controls. Knowing that I've already spent the majority of the time now with the animations, there was no going back. I had to make it work, with around about 3 weeks to the deadline. So I managed to rig and fix the movement where necessary by simply animating within Unreal Engine. And this is an incredibly large challenge because animating within Unreal Engine is very, very basic compared to Maya. Finally, finishing up the systems, I will quickly run down for all the features that made it into the game successfully with explanations on how they work and if they didn't make the list, and why they were cut out. Turnaround mechanics. This made it in. It had 2 essential changes, which I'll talk about later, but the one that made it into the game in its final development is working and operational, though it does have a large visual bug. This may be due to the animation and rig issues, though I can't be for certain. But it mainly functions by calculating the current velocity with the acceleration and giving a range output of 1 to -1. -1 indicating that you have started accelerating in the opposite direction. So when the value is less than 0, we can accurately assume the character is attempting to do a U-turn, therefore starting the animation. And then once it's done, we can add a notification within the animation to say, once you are done playing this part, you can now turn around again, if so desired, called an animation notification. And that way, we don't run into these issues where the character decides to never leave the animation and is glitched. Left foot, right detector. This couldn't make it into the game. Due to the rig issues and limitations, this wouldn't be possible to do without a rewrite of the animations and the rig itself. 8 directions of start. This is in the game. Each direction you can now see on the screen is in its respective direction. It also depends on what your speed is at as well, though in this game it doesn't translate well due to the fact that the base speed is running and it doesn't reach the desired acceleration within the short amount of time without the character seemingly reaching running speeds unnaturally. 1 direction spot. Works perfectly in game and out game, stopping the momentum flawlessly. Unsheathing mechanics. This works flawlessly due to delayed animation. This little tidbit was something I didn't know I could do until midway through the project. Luckily, I only ran into one problem, but it functions due to the fact that you can select which bones work and create a pose group. Using this group, you can then ask animations to only play on those selected bones like a necromantic puppeteer, and utilizing this and making it so that these animations have priority in the output. It will always play above the normal animation, leading to the character being able to run and still unsheath and sheath the weapon. Gesturing animation. I didn't create these animations during the time I was supposed to. I ran into issues with the rig, making this entire thing unable to be done within the short amount of time left. Directional movement and influence calculator. As mentioned earlier, this was the calculator for the original turnaround mechanics. It would allow me to know exactly where the player wanted to move the character and where the character was already facing. And Eventually it broke. Due to some other systems being implemented, it became redundant once I simplified the code with these two nodes, which then was placed around everywhere like a virus. But with the use of blend spaces within Unreal and these two nodes, I could create everything needed with more simpler maths and less resources. And for the turnaround, I just redone the code in a different way, swapped out the initial implementation for what I already have now. And it's far simpler and easier base for coding. Reaching the end, I found a few bugs and attempted to squash them, but even then I couldn't get them all. If it wasn't for these bugs and everything was implemented as intended, I believe that this system would be flawless. But the bugs, such as the turnaround glitch and having this issue, I now know how to fix these issues. But in the end, I did create roughly a total of 80 plus animations, each of them spanning from less than a second to 10 seconds. Showcasing now will be the vast amount of them at the same time. I would like to show you them all individually, but I cannot without surpassing the time constraints. Overall, the project was a minor success. I now know what is needed to create the vision I had within the first week. Each step-by-step detail on how to create flawless transitional movement without the use of Unreal Engine's motion matching. But with the creation of motion matching, my system wouldn't be as needed, as it would be far more complicated. But I'm still quite happy with the results in the end. And even though I ran into so many issues, it was still a great experience. And hopefully over summer, before my masters, I will recreate the entire project within the new Unreal update and be able to showcase even greater things for my portfolio. Thank you for listening.